is machine language. So processor can only understand machine language, that is zeros and ones, that is already pre-programmed into the processor by the manufacturer, okay, that is embedded into the machine processor. So let's take another example to see how difficult or how cumbersome it is. Processor A is embedded with the same set of instruction. Okay, look at 0, 0, 0, 1, 1 is for add, and 1, 0, whatever is for subtract. Right? So example, you have processor A. So if you want to say add 4 and 5, you can't say add 4 and 5. Right? You have to say something like this. This is add, right? See, 0, 0, 0, 0, 1, 1, 0, 0. Same thing. 0, 4 zeros, 1, 1, 0, 0. So this means in this processor A, that is processor A, this is add. Okay. Now 4. Okay, you give that. Then 4. 4 is, this is binary 4. Okay. 1, 2, 4. See, these leading zeros won't matter. 1, 0, 0 means 4. So this is also given. So add 4. Okay. And also remember why it is 8 digits is because the processor, the minimum amount it can work with is 1 byte. From the previous lesson we have seen that. So this is coming in 1 byte. Okay, this 4 will never be given as 100 because 100 means 3 bits. So the processor doesn't handle 3 bits, it handles 8 bits. So the rest of the bits you put zeros to make sure this is 4. Okay. Then 5. This, look at this, 1, 0, 1, 1, 2, 4, 4 and 1, 5. So this is 5. Okay. So this instruct, if you want to do this in this processor, this is what you give. So this is machine language, zeros and ones. So the processor will take that and add 4 and 5, process that, and 4 and 4 plus 5 is 9. So it returns 9, 1, 0, 0, 1. This leading there again because to fill the 1 byte. Okay. So this is an example of how the processor A will work with this instruction. Right. Let's take processor B. Processor B is add is different. Okay, as you see, this one's add and this one's add is different. This one subtract is similar to add here, but this is in this one it is subtract. So here again, if you want to give add 4, 5, same instruction now in a different processor. Earlier we gave this instruction for processor A. Now we are going to give the same instruction for processor B. Okay, for add 4 plus 5, same thing. So it goes as, now see, this time you have to write this, not this, because it's going to processor B. Okay, and 4 maybe same thing, 5 same thing, binary. Okay, so this goes into this and the result is again 9. So see, different binary values are going in here, especially this one, but the result is that because in this processor this is embedded as add. So when these things go into this knows these two have to be added, it adds that and returns the value. Again, this processor, when this comes in, it knows it's add and it adds these two and returns the same value. So if you look at the output, both are giving same thing, right? But input wise to the processor, we are giving add in this processor as this one, and in this processor we are giving this as the add. So that's the main difference. But you can see how much this machine language is dependent on the processor. Okay, only for that processor it will work, but the result is the same if this is the scenario. This is an example. Okay, right, let's see an example with humans. To understand that, let's compare a two human beings and see how what I'm saying there. I'm saying one processor won't understand other processor's instruction, and other processor won't understand the other processor's instruction. Only their own instructions they will understand, others instructions they won't understand. So I will show you that same example with a human. Okay, so let's assume there is a person here who can only understand English, and there is another person here who can only understand French. Okay, then there is a person here giving instructions in English. This guy only gives instruction in English. Okay, and remember this one only understands English, no other language. This one only understands French, no other language. Just like the two processors, we are taking these two examples, okay, A and B, two people now. And let's say there's another person who can give instructions in only, or he is giving instructions in French. This guy is giving instructions in English. This guy is giving instructions in French. Okay, so this guy will understand because he understands English. So when the English instructions come, he will be able to carry out that. He understands that. The English language is embedded into it, just like the processor A had its instruction embedded into it. Okay, so just think of it like that. But if this guy tries to talk to the French guy, he will not understand because he only understands French. Embedded into him is only French. French is embedded into him. So when this guy gives instructions to him in English, this guy doesn't understand what he's talking about because his instruction set doesn't support or does not know what this means. So he won't understand. Just like the processor B trying to get processor A's instruction. Okay. Same way, if you take the French person, him giving instruction to the French only guy, no problem, he will understand because it's French and he only understands French. That is inbuilt to him, embedded into him. So when he talks in French, he will understand. But when he tries to talk to this guy who understands only English in French, he won't understand. So from this you can see these things, right? When he speaks in English, only he can understand. When he's speaking French, only this person can understand, just like our previous example. Okay, right, let's take our imaginary processor A to further understand the problems in the binary machine language. Okay, assume we'll take processor A with those same two instruction set, and I want to show you some issues with the machine language. Also assume we want to give the following instructions to the processor A. That is, we want to say add 4 and 5, and we want to also say subtract 3 from 9. We want to give these two instructions, right? So we know subtract is this, add this. Okay, so let's see. So this above instruction, we can't give this now to the processor because processor only understands machine language, that is ones and zeros. You can't say add 4 and 5 or subtract 3 and 9. So in machine language, it will look something like this. Okay, let's see how this gets translated. The add part is this. Say add this 4 zeros 1 1 0 0. See 4 zeros 1 1 0 0. So this is the add, right? Then we have to have 4. So this is add. This is 4. Okay, in 8 bits. 0 0 0 0 0 1 0 0 1 2 4. That is 8. 1 2 4. This is 4. So this number is 4. So add 4 and then 5. Okay, so this is 4. This is 5. See 1 0 1. In again 8 bits. Why? Byte only the processor can handle. So it's going by 8 by 8 in this case. So this is 5. Right? Then that is not only only thing we wanted to do. No, we wanted to add as well as we want to do a subtract also. So then subtract comes after that. So this is 1 0 0 1 1 0 0. That is this one. You see. Okay. Then so that is subtract. Then we have the 3 in binary. See 0 0 1 1. That is 3. And then we have 9. Okay. See this is 9. 0 whatever 1 8 bits, each one is 8 bits. Okay, 8 of binary digits, and this is 9. So if you are seeing the machine language instruction to say add 4 and 5 and then subtract 3 from 9, it will be an instruction set like that. This is the machine language instruction for doing these two. Okay, so look at this instruction. The same thing I'm showing in another slide, same thing. So that's the machine language instruction. Okay, imagine a big set of instruction. Now here we are just talking about add 4 and 5, subtract 3 and 9. But generally when you are giving instruction, you give quite a lot of instruction to the processor. And just see, with two instructions, just add and a subtract, What you have is some 0, 0, 0, 1, 1, 0, 0, 0, 0, just imagine it will just only be like that, zeros and ones and zeros and ones and huge string of zeros and ones. Okay, so imagine a big set of needed to written in need to be written in machine language. This is machine language. Okay, this is machine language. You can easily miss a 0 or 1. And when you're writing like this, you can't be sure exactly whether you have put the correct amount of zeros and whether you have put the correct amount of ones. Are they correct or not? Or it's very difficult to visually recognize or identify. Okay, so you can easily miss a 0 or 1 here and there, and it will be very difficult to notice because it is in zeros and 1. So because of this reason, to overcome this problem, they have come up with a language called assembly language. Assembly language is introduced because of this cumbersomeness or difficult to read this issue. Okay, when you're writing in machine language, it's very difficult to read. It's all zeros and ones and zeros and ones, and very difficult to see whether you have missed out a 0 or whether you have missed out a 1, things like that. So to overcome, we use something called assembly language. So let's see what that is. In assembly language, instead of zeros and ones, it uses familiar words and numbers like add, sub to subtract, okay, and decimal numbers like 4 and 5, because here in machine language you don't use 4 and 5, no, you just use binary version of that. So in the assembly language, you will be allowed to use the commonly known number system, decimal number, and words like add and subtract instead of having to write all this. Okay, these English-like instructions in assembly language, that is add, subtract, and there are so many other things also. I'm just for convenience taking only 2, add and subtract. This abbreviation to indicate what we are trying to do. So as soon as you see the word add, you know we are trying to add. When you see the word sub, you know we are trying to sub. So that is known as mnemonics, abbreviations for languages. Rather than writing like this, we have more proper meaningful names for those, which are called mnemonics, pronounced mnemonics. Okay. So machine language instructions like that. Okay, which is the one we already saw. And now I'm going to write this in assembly language. In assembly language, it will look like that. Add 4, 5, subtract 3, 9. So just look at these two and this one. See how difficult this is to interpret and understand, and how easier it is to understand this. So that is why very convenient for people to read and write than machine language version. Okay, zeros and ones. See, just look at this and look at this. Same thing. This is same thing in machine language. This is same thing in assembly language. Okay.